In this video, we will discuss about marine robotics and meta-heuristic algorithm. So we will understand the role of meta-heuristic algorithm in marine robotics for different underwater challenges, like how we can use meta-heuristic in marine robotics for deep exploration. And we will integrate meta-heuristic algorithm with marine robotics. So first question is, what are marine robots? Marine robots are machines designed to work in water. They can either move underwater or on the surface. So marine robots are used to explore the deep sea, conduct scientific research, and perform challenging underwater tasks. You can see here early underwater exploration done by human divers. And now you can see we have advanced systems. We can use different AUV or ROVs to perform different dangerous tasks that is dangerous for the human divers. So now we have advanced robots. There are two types of marine robots: AUVs, that is autonomous underwater vehicles; ROVs, that is remotely operated vehicles. So first we have AUV. They can work on their own without direct human control, and they are used for tasks like exploring the sea, mapping the seabed, and monitoring the environment. Next we have ROVs, that is the remotely operated vehicles. They are controlled by human using a cable connected to the vehicle, and they are used for the underwater inspection, collecting samples, and repairs. For example, you can see here we have advanced AUVs like REMUS 6000, which can explore ocean depth up to 6000 meters. So marine robots are designed to operate in harsh and unpredictable environment of the ocean, and they are equipped with advanced sensors, communication technologies, modern engines. Next we have different applications of marine robots. Marine robots has a wide range of application from scientific research to industrial and military operations. These robots are used to map the seafloor, monitor marine life, inspect underwater infrastructure, and even assist in disaster response. So, first application we have on the scientific research. We can use in scientific research marine robots to explore and map the ocean floor, discover new species for geological formation, and hydrothermal vents. And they also use for environmental monitoring. They can collect data on oceanographic condition, track marine life, and monitor the health of ecosystem such as coral reef. Next we have different application in the industrial operations, like in oil and gas industry we can use ROVs and AUV. They can inspect and maintain offshore oil rigs, pipeline, and underwater infrastructure that reduce the need for human divers in dangerous conditions. And we can also use marine robots for the underwater construction, for building and repairing underwater structures such as cables and bridges. Third application for the environmental conservation, like for the pollution monitoring, robots can detect and measure the pollutants in the water, helping to identify source of contamination and assess the impact on the marine environment. Next we have in military and security. So marine rovers can be used for the underwater mine detection. So we can use here AUVs and ROVs are used to locate and neutralize underwater mines, ensure safe navigation for the naval vessel. Like that, we can see we have different application. Now we have different technologies used in marine robotics. So we have the key technology in the marine robotics, like we have different sensor. They are equipped with the different sensors, sonar, cameras, environmental sensor, and navigation system. Since GPS do not penetrate water, so marine rovers use acoustic signal for navigation and communication. Techniques like long waistline LVL and ultra short waistline USVL system are commonly used, and IMUs track the robot's movement to estimate its position when acoustic signal are not available. Next, we have sensing and imaging. Sound navigation and ranging system map the sea floor and detect object in water column. Cameras and LIDRs are used. That is the optical optical sensor capture high resolution images and the videos underwater, and LIDAR, that is the light detection and ranging, that can be used for short range mapping and the object detection. In the communication system, we have here acoustic modems. So these devices transmit data using sound wave, allow robot to communicate with surface vessel or other robots. And ROV often use cables for the reliable data transmission and power supply. So we have different challenges also. For example, like for the navigation and communication, it is limited by the underwater environment, and achieving accurate navigation is still a challenge. Next challenge, we have energy efficiency. So extending the operational time of marine robots require advancement in battery technology and energy management. Next challenge, we have environmental impact. So need to ensure that the deployment and operation of the marine robots not affecting the marine ecosystem. Next, you can see different algorithms. So marine robots relies on a variety of algorithms to navigate, perceive the environment, plan action, and communicate. For example, first we have here navigation algorithm like SLAM, that is the simultaneous localization and mapping. This algorithm allows robots to build a map of unknown environment while simultaneously keeping track of their location within that map. Different technologies used here like extended Kalman filter, particle filter, graph-based SLAM. Next, we have path planning algorithm. These algorithms calculate the optimal path for robot to follow, avoiding obstacles and reaching target location. Different techniques are used here like A star, dynamic window approach, and other. Next, we have sensing and perception algorithm. Here we have sonar processing. So we need algorithm for interpreting sonar data to create images or 3D model of the underwater environment. Techniques that are used: image reconstruction, beam formatting. Next, we have computer vision. Here different cameras and optical sensors are used to detect and recognize objects, track features, and perform visual odometry. So techniques that can be used here: CNN, convolutional neural network, optical flow, structure from motion, SFM. Next, we have control algorithms. Control algorithms, here we have two types, PID and MPC. PID, that is the proportional integral derivative control. So a control loop mechanism used to maintain a desired set point by adjusting the control input based on the error between the desired and the measured value. PID is used here for maintaining position, depth control, and heading control. Next, we have MPC, that is the model predictive control. That is an advanced method of process control that use a model of system to predict future state and optimize control input. MPC is used for the dynamic positioning and the trajectory tracking. Next, we have data fusion algorithm. Here we have Kalman filter, particle filter. Kalman filter, that is an algorithm used a series of measurements observed over time containing statistical noise and other inaccuracies and produce estimate of unknown variables. It is used for sensor fusion for combining data from IMUs, GPS, sonar, and other sensors. Next, we have the particle filter, that is a sequential Monte Carlo method used for implementing a recursive Bayesian filter by Monte Carlo simulations, that is used for the state estimation and SLAM. Next, we have the machine learning and AI algorithm. That is, here we have neural networks and the reinforcement learning. Neural networks are used for the pattern recognition and learning from large data set to make predictions or decisions. So neural networks are used in the marine robots for object detection, behavior prediction, and the classification. Reinforcement learning, that is a type of machine learning, where an agent has to learn to make decision by performing action and receiving rewards or penalties. This one is done for the adaptive control and the autonomous navigation. So, as we discussed before, we have a number of challenges in navigation and communication, energy efficiency, environmental impact. Now, we will try to solve these challenges by integrating matter-heuristic algorithm with marine robotics. So, as we know, matter-heuristic algorithms are designed to find optimal or near optimal solution to different complex optimization problems. So metaheuristic algorithm can be highly effective in marine robotics. They can be useful in marine robotics for tasks like path planning, resource allocation, sensor placement, and system design. For example, in path planning, the challenge is finding the most efficient route for a robot to take while avoiding obstacles and minimizing energy consumption. Solution we have here, we can use meta-heuristic algorithm like PSO, genetic algorithm, ACO that can optimize the path planning process by exploring numerous possible paths and selecting the best one. Next, we have task allocation. Challenges we have assigning tasks to multiple robots in a way that maximize efficiency and minimize time. So solution we have here, we can use meta heuristic to allocate tasks dynamically, ensuring that each robot is optimally used. For example, we can use whale optimizer, artificial bee colony. They can help distribute tasks among robots. For environmental monitoring, challenges efficiently covering and monitoring large areas of the ocean to collect data. Solution, we can use meta-heuristics. So meta-heuristic algorithms can optimize coverage patterns of multiple robots, ensuring that they cover the area without redundancy and with minimal energy use. Here we can use simulated annealing and harmony search. Next, we have energy management. Challenges managing the energy consumption of robots to extend their operational time. Solution, we can use here differential evolution, gray wolf optimizer, or any other algorithm. They can help in optimizing energy usage pattern and scheduling recharging activities. Last, we have the localization and the mapping. Challenge is to create an accurate map of underwater environments and determining the precise location of robots. Solution, we can use metaheuristic to improve the accuracy and efficiency of the simultaneous localization and mapping processes. Here we can use Firefly algorithm to enhance mapping accuracy. So like that we can use number of meta-heuristic algorithm and we can test whether they can solve the challenges or not. So by integrating meta-heuristic algorithm with marine robotics, we can enhance the efficiency and effectiveness of the marine operations. And these algorithms also provide us the worst solution for the optimization problem, that is making the marine robot more capable and reliable in performing their task. So we can create an hybrid approach in marine robotics by combining meta-heuristic algorithm with other techniques to enhance performance and efficiency of the marine robots in various tasks. Benefits of using hybrid approaches is we can improve performance, scalability, adaptability. We can combine the strength of different algorithm can lead better performance in terms of accuracy, efficiency, robustness. And the hybrid approaches can adapt to dynamic and uncertain underwater environment. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.